Course 3, Lesson 29 and Lesson 30. So in the first one, we're going to be looking at ratios. So your goal is to be able to write ratios in multiple different ways. And then Lesson 30, we're going to be looking at repeating decimals. But first, let's talk about our ratios. With ratios, we're talking about this division relationship that compares two numbers. So we can write them in a few ways: as a fraction, as a relationship with a colon in the middle, or with the word 2 in the middle. So if we are looking at this aquarium here, we could say, all right, if we want green fish to orange fish, we can describe it as 2 to 5, as 2:5, or 2/5. Because those green, we have 2, orange, we have 5. Very important to keep those in the correct order based on what you're asking for. Now, if we're looking at the ratio of black fish to red fish, we would say we have 2 black to 3 red. We can show that as a fraction too. And in the second one, we see we have 4 black fish to 6 black fish, 4/6. But when we look at these, we say, well, isn't that the same ratio? We would say yes, because these reduce to 2/3, or 2 to 3. We want to show them in the simplest form possible. So when we are matching some of these equivalent ratios, we would say, what are some that can reduce down to each other? And we would say, okay, 6 to 60, well, that's the same as 1 to 10. Or 9 to 12, that's the same actually as 6 to 8. Each of them is 3/4, which means that, well, that also works with this one here too. So all of those 3 would work. 5 to 2, well, that's the same as 10 to 4 over here. 3 to 15, well, that reduces to 1 to 5. And 5 to 6 reduces to, or 10 to 12 reduces to 5 to 6. The only one that's left out that doesn't have a pair is that 10 to 5. Now, if we were to use some of these ratios for like a recipe, like orange juice to water, we would say, if I have 1 part orange juice and 5 parts water, I can make a ton of different batches, right? So if we have this ratio of 1 to 5, that means if I have 1 quart, that means that I need 5 quarts of water. And same with, okay, if I have this ratio 1 to 5, if I have 2 gallons of orange, that means, well, that's times 2, so I would need 10 gallons of water. And lastly, if I still have my ratio of 1 to 5, if I have 30 pints of water, notice that I don't put it next to the 1, I put it next to the 5 for the parts of water that I need. I would need, well, that's 5 times 6 is 30, so 1 times 6 is 6 pints of orange. Okay, so we can use this idea of our ratios and scale it up or scale it down. Really, what we're doing here is proportions. That's what it's called, proportions. So if we have 9 girls and 15 boys in the class, what's the ratio of boys to girls? Well, we would say that's 15 to 9, but we want to reduce that. Each of those can be divided by 3, so we would say that's 5 to 3. Girls to boys, we would say, okay, 9 to 15 now, which is the same as 3 to 5. And we could show these as our 3:5 or our fraction or with the word 2. And then if we did all of these, we could also divide them and put them in a decimal. Now, if we were given this information, these are our last 2 for this section. A 30-foot tall tree casts a shadow of 18 feet long. What was the ratio of the height of the tree to the length of its shadow? Well, if we have this 30-foot tall tree, that's the height of the tree. That's what they want first. So we'd say, okay, 30 to its shadow, which was 18 feet. Well, we can reduce this and divide each of those by 6 and say that we have 5 to 3. The ratio is 5 feet to 3 feet. And lastly, at the high school football game, 1,217 fans sat on the home team side and 896 fans sat on the visiting side. What is the approximate ratio of home team fans to visiting team fans? Well, I am going to round this to the nearest hundred and say I have 1,200 home team to 900 visiting. Well, I can reduce that by quite a bit. We can get rid of the zeros by dividing by 100, and then we just have 12 to 9, which we can reduce that and divide each of those by 3 to get 4 to 3. So the ratio of home team to fans to visiting is 4 to 3. So that's all we have really about ratios. Here's a few other examples if you would like to go through those. Now let's talk about our repeating decimals. Repeating decimals, so your goal is to be able to write repeating decimals, compare and order them, write fractions as decimals, and convert rational numbers from fractions to decimals. Well, first let's get some terminology straight. So terminating decimals, these are the ones that come out even, they stop, like 0.126, 0.9, 0.34. If we were to continue these on, we would have zeros at the end of all of these. That means that we don't have any more information. These are terminating. Whereas repeating decimals, we would say these are decimals that never stop and form a pattern of repeating numbers. We represent them with a bar called a repetent, and it goes only over the ones that need repeating. So like if we have 0.333 forever, we would also write this as 0.3 with a bar over the 3, showing that it goes on forever with that 3. Or 0.121212, we'd say 0.12 with a bar over both the 1 and 2, because those alternate and repeat. Whereas this next one, 0.83333 forever, we would only put the repetent bar over the last number, that 3, showing that the 8 doesn't repeat, only the 3 does. So if we want to change a fraction to a decimal, as we all know, we just divide. We take the top number and divide it by the bottom. So the top goes in the house, bottom goes outside of the house. So if we were to try like 7 divided by 8, we would do something like 7 in the house, 8 outside, and we would need to add a 0 and say, okay, 8 into 70, well that could be 8 times to get us 64, so we have 6 left. And 8 into 60, well I could do that 7 times to get 56. 4 left over, and well that turns out nicely because I have a 5 that I can get that 40 from. So this is a terminating decimal of 0.875. And then if we do 3/5, well all we do is 3 divided by 5, and see we have to add a decimal, and it's 0.6. So this is also a terminating decimal. Let's try some other ones. 8/3, so we would take 8 and divide it by 3 and see, okay, that can go in twice to get 2 left over, but we have to add a decimal. Okay, and we can get 6 in there, 18, so we have another 2 left over. And once again, we can get 6 in there, and once again, we have a 2 left over, which means we are going to repeat. We have 2.6 repeating. That 6 is going to go on forever. Okay, so we have a repeating decimal. Let's see, this 4/11ths. We're going to do 4 divided by 11. So that means that we can get 3 in there. So we have 7 left over. And another 0 comes down. And we can get 6 in there. So we have 66 with 4 left over. Interesting. We get another 40, so we have 3 in there. And then we're going to get another 6, and another 3, another 6. So we actually get 0.36 repeating. Okay, 0.36 repeating. Wonderful. Here are a couple other examples that you can try. 5 divided by 6, 7 divided by 12 to decide are they repeating or are they terminating. 11 divided by 15, 8 divided by 9. And when we have a mixed number, really all we just need to divide is like the 5 divided by 16. And if we did this, we could say, all right, 16 into 50, well, that can happen 3 times. Okay, and we get 48, so we have 2 left over. And we could say, all right, 16 and 20 can happen once, so we have 4 left over. And 16 into 40 can happen twice with 32. So we have 8 left over. And 16 into 80 is a 5 exactly. So we have nothing left over. So we see I can just take the fractional part of my mixed number and divide it and get I have 6.3125. This is a terminating decimal. Whereas if I did negative 3 and 5/11ths, I would see that I would get negative 3.45 repeating, and you can try that on your own. But really you only need to divide the 5/11ths. Yes, you could turn it into an improper fraction. It's not necessary. Now the last part of this lesson is being able to order numbers, especially our decimals, least to greatest. So I'm going to help myself out and write some of these repeating decimals with a couple of their decimals, like 1, 3, 3, 3, okay? And I'm going to write them just with 3 decimals, so let me get rid of one of these here. So I should have 0.133, okay, knowing that it goes on again. Okay, I'll do another one. And then 0.1.131, and I have a 0 after that because it doesn't go on forever. And then I have 0.1313, and I could go on, but then I have 0.1330. So if I were to look at all of these with their 4 decimal places, I could say, what's my smallest? Well, that would be my 0.1310. It's like having 1,310. Whereas next I would say, okay, it looks like this 1313 would go next, 0.1313. And then I would say, okay, is my 1330 or my 1333 bigger? Well, it would be the 1333, so my 1330 comes next. And then my 0.1333. So I'm going to put these back and in their original form. So 13 or 0.131, 0.13 repeating, 0.133, and we have 0.13 with the 3 repeating. Okay, so that's how I would go about with these examples of putting them in order from least to greatest. So another couple examples here that we have, I'll do this one here, and you can try the other one on your own. So let's put them all with our 4 decimal places. 0.2666, 0.2660, 0.2626, and 0.2620. So when I look at these, I say, all right, the 2666 and 2660 are bigger than my 2626 and 2620. So I would say my 0.2620 is going to be bigger than or smaller than my 0.2626. Then comes my 0.2660 and my 0.2666. So putting them back into their original, we have my 262 thousandths, my 0.26 repeating, my 0 and 266 thousandths, and my 0.26 with the 6 repeating. Okay, so there's one more that you could try out, and then you can figure out what order they should be in. Well, I hope this is helpful for your homework and for studying.